Okay, so moving on through this geometry chapter, chapter 4, we're actually going to finish it today, so it's the last of sort of the basics that we need to talk about. So the first thing here is perpendicular and parallel lines. You probably know what perpendicular and parallel lines are, but just to go through it. So perpendicular lines are at right angles or 90 degrees to each other. See, this here is an example of a perpendicular line. Okay, they literally cross each other the same way, like if you're doing the letter T, that you have a perfectly horizontal line and perfectly vertical line, so they meet each other here with a right angle. Okay, so they cross at right angles. So like for your notes, there you go. Perpendicular lines are at right angles to each other. And the line L, so this is the line L, you can see a little L down here, and the line M, so that's over here, are perpendicular. Now, a little symbol, okay, that's important. So this is your next bit of notes here. Again, maths, we love symbols, so we don't write L as perpendicular to M, we write it like this. Okay, L, and that means this symbol here means is perpendicular to. Okay, so for your notes, you would want a little heading, perpendicular lines. You want to write down perpendicular lines are at right angles to each other. I would draw two perpendicular lines and then take note of the symbol for perpendicular lines. Okay, and then parallel lines. I think I've definitely asked you this in class before, so I know you know this one. Parallel lines are always the same distance apart and therefore they never meet. So here's your parallel lines here. No matter how long, if they're a line and lines continue infinitely in both directions, if you were to continue this line up this way and this one up this way, they're the same distance apart, so they would never cross. And likewise down here, if you were to continue, they'd never meet. Okay, so that's what a parallel line is. Symbol. So the symbol for perpendicular is literally two perpendicular lines. Okay, and the symbol for parallel is two parallel lines. P is parallel to Q. Okay, so again, make sure you take down the description of what is a parallel line, draw the picture of the two parallel lines, and take down what the symbol is. Okay, now I don't know, is it mentioned? No, it's not mentioned. So just to make a note that there is kind of a symbol on the diagram then to let you know that they're parallel. So see these little arrows here? Okay, if you have two lines that look parallel, but they don't have those little arrows on them, then they're not parallel. Okay, so that's like another symbol on the diagram to show parallel lines. Okay, so if you have two lines and they look sort of parallel, but they don't have those arrows, then they're not. And actually I should mention that up here too. I know I mentioned the symbol before, but there's one symbol and there's the other symbol for right angle. And if you're looking at a diagram like next week or whatever, and you think, God, those two lines look like they're meeting at 90. If the symbol isn't there, they're not meeting at 90. Okay, so both of those symbols are important in the diagram to let you know that the lines are exactly parallel or exactly perpendicular. Is that okay? So we actually kind of have four things. The description of the perpendicular line, the symbol for perpendicular out here if you're writing it, and then in the diagram, draw perpendicular lines and also stick in the symbol for perpendicular. And likewise over here, parallel lines, symbol for parallel if you're writing it. Draw your parallel lines and the symbol in the diagram to show that the lines are parallel. Okay? And then here, again, I'm sure you know this, but what is a horizontal line? So horizontal, we think of the horizon. Okay, so that is a line from left to right. And a vertical line goes top to bottom. Okay, so then this, we would have come across this before. This would be your x-axis, a horizontal line. And this one here would be your y-axis, because that's a line that goes up and down. Yeah? Okay, next thing here is axioms. These were kind of never mentioned on the old course, and then when the new course came in, they decided they needed to talk about them. I'm going to talk about them very briefly. So, an axiom is a statement that we accept as true without any proof. Okay, and the reason we accept it as true without any proof is because it's really bloody obvious. Okay, there's 5, I think, and here. This is where they are in your book, okay? Because I'm not putting them all in here, nor am I going to make you write them all down because they're not the kind of thing you learn, okay? It's more, these are things you should know. And most of them, like here, first axiom, it's called the 2-point axiom. There's exactly one line through any 2 given points. So if I gave you 2 points anywhere on a graph, and say I gave 2 points to one student at the front of the class, and I gave the exact same 2 points to another student, photocopied it, same 2 points to another student at the back of the class. Or I gave it to one student in Robinson, and then one student in Higgins, and one student in Macaulay. Okay, so they couldn't see each other. But I gave everybody the same 2 points. Would they draw the same line? Like, of course they would, because there is only one line that you can draw if you're given the exact same points. You draw from one point to the other point. Okay, and providing you draw a straight line and the points are as small as they possibly can be, everybody should draw the same point. Okay, so that's the first axiom. Now I'm just going to go to page 61 here. So the second one is the properties of the distance between 2 points. Okay, the distance between 2 points is never negative. Okay, that makes sense if it's a distance. If there is a distance between 2 points, then there's no way that could be a negative distance. A negative distance doesn't make sense. And the distance between A and B is the same as the distance between B and A. So that essentially means that if I said, oh, I can't write here, but like, so here's A, you see, here's A, and here's B. If I asked one person to measure with a ruler from A to B, and I asked someone else to measure from B to A, would they get the same answer? Yes. Okay, if point C lies on AB, then the distance from A to B is equal to AC plus CB. Okay, so what they're saying there is that if C is on the line, right, see C here, and it's in between A and B, do you remember that word? They are collinear, okay? Then the distance from A to B, right, so right from this end to this end, is going to be AC plus CB, which makes sense. So the 2 bits of the line equal the entire line. Given any ray from point A and given any real number where k is greater than 0, there is a unique point B on the ray whose distance from A is k. Okay, ugh. This property means that if we mark off a distance 5 centimeters on a ray from point A and call this point B, there is no, yeah, okay. So what they're saying there is that if I give you point A and I draw the ray, so remember a ray is a line that kind of has a start point but continues on forever. So I draw a big long line for you, and I tell you to put the point B 5 centimeters away from A, that everybody would put it right here. Okay, because there's nowhere else. As in, that is the only point that is 5 centimeters away from A. Okay, so this kind of goes on. There's axiom 3, the properties of a degree, the number of degrees. So a straight angle always measures 180. We talked about that the other day here. Remember when we started the rotation and rotated up, 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 and got around to a straight line, that it was 180 degrees. Given a ray AB and the number D between 0 and 180, there's exactly one ray from A on each side of AB that makes an ordinary angle having D. What? The property of the protractor axiom means that, for example, there's only one 60. Yeah, okay. So if you were to go 60 degrees up and 60 degrees down from this ray here in the middle, there is only one 60 degree up and there's only one 60 degree down. Again, if I were to give it to 2 people, everybody would end up with that same picture if I gave you a protractor. Okay, and this is the same as the other one. This is the, if you measure the angle to the orange one there all the way from A to C, and then you measure the broken up bits, that the 2 little angles will equal the big angle. 1 line through P. Okay, so if I gave you this line L and I gave you this point P, there is only one line that you could draw that would be parallel, because if you drew it at any other angle, it would go off and it wouldn't be parallel and the lines would cross. Okay, so I didn't want to not talk about the axioms because they're clearly in the book and I didn't want to ignore them, okay? But they are all statements of fact. They're all things that are really obvious that you already know. But then they say them in a really complicated way and make it sound as if, like even me reading them, I'm like, what in the name of God are they talking about? Now, to be fair, they do explain it like in more regular English down here. But these are not something you need to worry about. So what you need in your notes is what is an axiom. An axiom is a statement that we accept as true without any proof. By all means, read through page 61 and 62 if you really, really want to. I've kind of just read through it there anyway. But the actual contents of the axiom are things that you know already and things that you will never be asked to explain. Okay, so hopefully that's all right. Right, so we're going to look at an example. Actually do a bit of maths. We haven't done in like 2 classes. Okay, so AB is a line as shown. So here's AB. Maybe go a bit thinner than that. Here's AB along here. What type of angle is? Now, let's have a look at this thing here. Okay, see this thing here? So we've this symbol, and then we have A, B, C. Now, this symbol means all they're telling you is that what they're about to talk about is an angle. So that symbol, when we read it in English, we read the angle. So I read this sentence, what type of angle is the angle ABC? Okay, so that little symbol here, it looks like it's actually just a little acute angle. That's what it is. It kind of looks like an L, but it's not meant to be like this. It is actually meant to be like that. Okay, so it's an acute angle. So what type of angle is, translate the angle ABC. Okay, and when you read an angle ABC like that, you'd kind of trace it. Okay, so I start at A. See me over here at A? So A, go to B, go to C. So this is the angle they're talking about. Okay, you always look at the one in the middle. Okay, so if you look, the angle I'm looking at is at B. Okay, so this symbol translates to the angle. ABC, you literally trace that. Now, you don't need to draw it the way I did. You just trace it with your eyes or whatever, but it's start at A, go to B, go to C, and then the angle they're talking about is the one in the middle at B. Okay, so they're asking us what type of angle that is. So if you look at that angle there, that is based on what we learned. Which class was that? It was a Friday. That is an acute angle. Okay, it is an angle that's bigger than 0 and less than 90. And without using a protractor, find the measure of that angle. Now, just take this off. So, sorry, go one more. Yeah. So, this angle here, yeah, is what we want. That's our little question mark. But what's this angle here, the big angle? What kind of line is that sitting on? Okay, that whole thing, that whole black angle there is sitting on a straight line. And we know from earlier that a straight line contains 180 degrees. Okay, we did those rotations in the first class, or the first geometry class, I think it was Wednesday. And a straight angle contains 180 degrees. Sorry, a straight angle contains 180 degrees. So, if this side of it is 130, then what's this side of it? So all we have to do is do 180 degrees minus 130 degrees, and that leaves us with 50 degrees. Okay, and that was one of the axioms, that if you break up a big angle into 2 small angles, the 2 small angles have to add to give you the big angle. Okay, so if we just do, we know that a straight line is 180. We know that this side is 130, so if we do 180 minus 130, we'll have the bit that's left, which is 50. So when we're writing our angle, we say the angle ABC equals 50 degrees. And it's a nice simple subtraction. Now make sure you understand what I'm talking about, because when we get into the theorems in the next chapter, remember the facts I told you we had to learn about triangles and stuff? I'm going to keep adding on to this, right? So this is kind of, it's not a theorem, but it is a fact that a straight angle contains 180. And this is a fact now that you need to remember. And in about 20 seconds, I'm going to add a second fact to that. And then when we get into the next chapter, I'm going to keep adding facts until you end up with, I don't know, are there 21 of them or something? So it's quite a lot of facts about lines and angles and triangles that you need to remember. Okay, now to be fair, I think it's 21 for junior cert higher level maths. I'm not going to teach you 21 in the next week. But the point is that these all have to be retained so that when you look at a picture, you have all this, like, it's almost like a little tool bag, and you have all this armory. So you look at a picture and you go, what do I know? Oh, I know that a straight angle has 180. I know this, I know that, I know the other, and see what will help you. They're just like little puzzles. So anybody, and I know there's a load of you that like puzzles, when we get into these properly, they're just like puzzles, and you just have to be like, okay, what do I know about lines? What do I know about angles? Okay, so it's all those notes you took down the last day, the last couple of days, and obviously what I'm telling you today, they need to be built up into a bank of knowledge that you have to kind of commit to memory. Okay, so we look at this. The glaring thing that stands out to me, and the first thing I highlighted, was that straight line, because that was everything I needed to know about this question. I see the straight line and I say, I know the straight line is 180. And then this line down here is splitting up this big angle, which I know is 180. So it splits it up into 130 and something. So I just subtract. Okay. Oh, please don't do that. Right, sometimes it flicks back. Hopefully try and ignore that. Oh, yes. Okay. Now, using your knowledge of geometry axioms, find the angle. Now this thing here you won't have seen before, I don't think. So we know that this little thing here means the angle, okay? The two straight lines, I can't remember if we talked about, I think we did. So they can be used for the length of a line, those straight lines. They can also be used for the size of an angle. Okay, so using your knowledge of axioms, find, I read this bit as the size of, this bit, the angle, and then this thing here is the Greek letter beta. Okay, so it's just, sometimes the English alphabet is not enough, so we have to stretch out and use the Greek alphabet. We actually use the Greek alphabet an awful lot in maths, and you'll see questions like this where they just introduce a little bit, because like leaving cert higher level maths, we use an awful lot more alphas and betas and gammas and stuff like that. And if anybody ends up in leaving cert physics with me, we basically use the whole Greek alphabet in physics. So it's just as simple. It could as easily be, X. It's literally just a symbol to mark this missing angle. Okay, so a couple of symbols there. The straight lines can refer to the length of a line. Obviously it doesn't here, because if you look at beta, it's clearly not a line, it's an angle. So the other thing, or it can mean the size of the angle, or it should be the size of. This here, remember, stands for the angle, and then this B looking thing is the Greek letter B, which is called beta or beta. I call it beta. Okay, oh, it says it there. Beta is the second letter of the Greek alphabet. Didn't see that. Okay, so here, what's the glaring thing that stands out? Where the last time it was the straight line, here we have a nice big circle. Okay, that is referred to as a full angle, again from your notes, and a full angle contains 360 degrees. okay? That full angle is split into 3. So essentially what we have is we have 80 degrees plus 155 degrees plus whatever beta is, and all that has to add up to 360 because we know a full angle is 360. Okay, so I'm going to add together 155 and 80, so that's 235. So 235 plus the missing angle, which is beta, is 360. So hopefully you can see that it's 360 minus 235, and we get 125 degrees. Okay, so we would write the measure of the angle beta, or the size of the angle beta, is 125 degrees. Okay, right, so that's it for that's actually it for this chapter. That's chapter 4 done. So not as heavy on the notes there today. You literally just have to take down perpendicular, parallel, horizontal, vertical, and literally just what is an axiom. Yeah, and then the 2 little questions. Okay, so they're really, like, we learned some other, like, obviously we learned about right angles as well. So there could be a question on right angles, and that they give you a little right angle and then split it up. Of course there could be. But what we did there was the straight angle, which is 180, split in 2, and we did the full angle, which is 360, split in 3, and we figured out the missing angle. Okay, so take down your notes, and I think I gave you like 3, maybe 4, I can't remember, to be honest, but a couple of these little questions, which ultimately boil down to a subtraction. Okay, again, please, please, please don't just give me the answer. With these questions, actually I should have said this, with these questions you kind of have to give a reason. So normally when you're asked these in a paper, they ask you for the answer, and then underneath they ask you for like a reason or a justification. So you would have to write down, see the way here I have straight angle contains 180, and here I have full angle equals 360. You need to give them your reason. So, like, why am I doing all this down here? Why am I minusing 235 from 360? I'm doing it because I knew a full angle had 360. So make sure you include a justification. Now, I've pretty much given you the only 2 justifications you know already, so just make sure you write it down. Or even if you don't write this as a fact, show me your work, like do 360 minus whatever, or 180 minus whatever, so I can see the 360 or the 180. Does that make sense? Please don't just write down 125. Okay, hopefully we're near the end of first year now. I'm killing myself telling you to show your work. So please show your work. All right.